Alright, third and final example for the night, and then we'll look at some things when we get into class tomorrow, alright? Okay, so here we're going to graph one final quadratic. You remember what we do first? Y-intercept. That's right. Now you don't actually have to do the y-intercept first. Okay. Now on the y-intercept you make x equals 0. Okay. Now the reason why it's nice to do the y-intercept first is because all of these equations will have a y-intercept. Okay. Negative 0 squared is 0 minus 1. So the y-intercept is negative 1. So we can put that down. Okay. Now, next step we would do the x-intercept normally, right? Okay, so the x-intercept means that y equals 0. So we make that 0. And we go negative x squared minus 1. Okay. And I'm going to add the 1 to both sides. You could do the quadratic formula on this. I'm just going to, since I only have the x squared, I'm going to go ahead and just solve it this way. Now you'll notice when I do that, and now I'm going to take the square root, right? Because I got the x squared, I want to do the opposite inverse of the square to get it to cancel out. I end up with the square root of a negative here. What does that mean? Yeah, that means it's not possible. No solution there. Okay, if you would have done the quadratic formula, the negative b plus or minus the square root of b squared minus 4ac all over 2a, if you would have done that, you would have ended up with a negative right here inside this, which means still you wouldn't have been able to do it. Okay, so what that means is that this graph does not have an x-intercept. It means the curve doesn't cross the x-axis anywhere. Okay, not even at a decimal. It doesn't cross it at all. Okay, so what do? We can't use the x-intercepts to find the vertex this time. We do have the y-intercept. Well, in this case, all we can do is try to plug in some more values, right? We can make the table, okay, x and y, and let's put in a couple more values that are around this one, okay, because I know it comes here, so let's just take a couple of x values. So I'm going to put in 1 and 2 and maybe negative 1 and negative 2. Let's try those to start with. 1, 2, negative 1. Let's just try those to start off with. So y equals negative 1 squared minus 1. So I do 1 squared, which is 1. I make it negative, so that'll be negative 1 minus 1, which is negative 2. Alright. Now let's go ahead and do 2. So let's go y equals negative 2 squared minus 1. So 2 squared is 4. Make it negative. So negative 4 minus 1, which is negative 5. So there's that one. Okay, and let's go ahead and put those 2 points on. So I've got 1, negative 2, and I've got 2, negative 5. Alright, so you can kind of start seeing what it looks like. Now we don't know if it keeps going up here. Now remember, it can't cross the x-axis, so we don't know if it keeps going up here and goes back down that way, or what it does. So let's go ahead and let's plug in something on this side. Let's put in negative 1 like I had there. So let's go y equals, and I'm going to change colors because I don't know if this one's going to show up. So let's go y equals negative, now this time I'm going to put in negative 1 squared minus 1. So negative 1 squared will be 1. Make it negative. So negative 1 minus 1 will be negative 2. Right? So if I put in negative 1, I get negative 2 out. So negative 1, negative 2. So can you see how this one is an exact reflection of that one? Where would the mirror have to be? Where would the axis of symmetry have to be in order for that to reflect? Hopefully you notice that again in this case it's going to be right down the y-axis. Okay, don't get in the habit of that because it won't always be the case. But you can see how that's one space over and that's one space over. This is smack dab right in the middle. Okay, so you should be able to make sense that that one's going to reflect over on this side. And that's going to be what my graph looks like. Okay, so that's it. make sure you get those notes down. We'll look at it again in class, and we'll spend some time on it there, all right? Okay, and see you later.